So the history of space exploration, as you know, it almost started, we can say, that the beginning of 1900s. Okay, especially an official data or official person who studied about rocketry more scientifically. So I'm not saying that the rocket technology or the technology like the reaction devices, or we can call it as a reaction engines. So usual engines are something different with a wheel or something like that, but in this case the reaction engine means, or a reaction vehicle means, it works on the principle of action and reaction. That is, as you know, that is the basic working of what is the pattern of our final X. Okay, that everything is included in the final slide. I will give you a brief intro about our how is your exam, and as you know, the pattern you might already know, but anyway, I will give you repeat it once again. So reaction device means it works on the principle of action and reaction. Okay, so action and reaction, you might already know that when a gun fires, actually this gun will recoil in the opposite direction. When the bullet goes in this direction, the run will recoil in this direction. This is exactly what is called the reaction. So if you take the bullet's motion is as the action, the opposite movement of the gun is actually the reaction. So it happen as a pair, action and reaction will be there. And the same way the rockets also working on the same way. Okay, so it is basically by the reaction it is actually going up. Okay, so that is why we call them as reaction devices or reaction engines or reaction vehicles. Okay, so here you can see if I place a nozzle here, so that exhaust is actually at a high velocity going through in this direction. So that is sorry, let that be action. Then the movement of the rocket itself, the rocket body itself, in the upward direction, or the thrust that is got by the uh, received by the rocket is actually the reaction. So that is why it is called a reaction device. Okay, so now this kind of devices were there. So basic rockets or cannons that used for war, even some even before 1900s or 1400s, or all it were there. Okay, but anyway, it wasn't a scientifically studied thing or scientifically guided thing. So when there is a cannon or something, it is actually going in a particular direction, that's all. So the amount of fuel, or it is not calculated scientifically. So that is why we call it as or more theoretical studies are not there. So that is why we are not including that as the history of rocketry. But anyway, we can actually include that as well. But here we are actually starting from an official study that happened by the Russian school teacher called Siolsky. And he is a Russian school teacher, and he written an article called Exploration of Cosmic Space by Means of Reaction Devices. So this is reaction devices. And up to his death in 1935, Siolsky continued to publish sophisticated studies on the theoretical aspects of spaceflight. Okay, so he is not a kind of a experimental person. He is something like a theoretical person who devised or he written many papers and on this rocket technology. So that is what he did. Then the next person comes, that is the Goddard. Okay, so you might know the Goddard Space Flight Center, that is actually named after him. So he's in US, and an interesting thing, even he was kind of a dreamer. Actually, he had a very good vision. Even at high school, you can see it is difficult to say what is impossible. Okay, see, it is difficult. He is saying it is in 1904. For the dream of yesterday is the hope of today. Okay, for the dream of yesterday is the hope of today and the reality of tomorrow. See how intriguing this quote is. Okay, so it is something like he already had that dream in his mind, especially about the rocket. And an interesting thing is that Goddard actually claims that rocket could be used to send objects as far as moon. Okay, so just imagine that he is talking this in the year of some 1910 or something like that, or 1915, something like that. After his high school, he's saying something like that. Then the public press actually ridiculed him. So people thought that he is actually saying some blunder. I don't know whether it happens or not. Okay, anyway, maybe at that time it was a funny thing or to mock at a person. Okay, but later, you know, that after 1969 itself, in the same century itself, actually, man went to the moon using the rocket technology. Then at that time, actually, New York Times specifically written an article on this and saying sorry to this Goddard, that what they published in the public press at that time was wrong, and they actually retracted that news officially by saying okay. And his first rocket actually launched in Massachusetts on 16. Just a second. Just hold on. Okay, in Massachusetts on March 16, 1926, and it rose just 12.5 meters and travels 56 meters from the launching place. But anyway, that is the way, and he is actually working at the Massachusetts, and you can see, since it is a rocketry experiment, like mostly it is explosive, especially the fuel is basically explosive, so it was difficult to have the learning or this experiment there. Uh, So what they did is, just a second. Okay. So what they did, he actually moved to New Mexico, where 1930 to 41 he built engines and launched rockets of increasing complexity. Now the if you take the important persons in the history of rocketry, another important person is Oberth, and the third widely recognized pioneer of rocketry, Hermann Oberth, was a German national. And Oberth, again, he also rejected, basically, you can see in 1922, doctoral dissertation on rocket-powered flight was rejected by the University of Heidelberg. Then the work explained the mathematical theory of rocketry and applied the theory of rocket uh, design and discussed the possibility of constructing space stations and traveling to other planets. Okay, his works led to the creation of a number of rockets club in Germany. So this is so important. Okay, so a number of rocket club actually started in Germany, something like the astronomy club, maybe rocketry club were there. Even nowadays there are people who even do rocketry, but now the rules are so strict, so you cannot actually. But there are people who does simple rocketry, not the big one. Okay, that anyway we cannot do easily. Okay, anyway, rocket club, and such an important group was there, that is a VFR, that is in this is the name that is in German, but actually it is translated to Society for Spaceship Travel. Okay, so which had as a member the young Wernher von Braun. Okay, so he is also an important person in the history of space. Okay, you will see that where it comes into the NASA and all, you will see this person is there as well, even though he's a German. Okay, although Oberth's work was crucial in simulating the development of rocketry in Germany, he himself had only limited role in the development. Okay, he worked mostly in simulating and theory. Okay, an interesting thing, see his his doctoral research actually rejected in 1922 because on the rocket powered flight, but since after that the scientific community came to know that it all works, and alone uh, among the rocket pioneers, Oberth lived to see his dream come reality. He was the bronze guest at the July 16, 1969 launch of Apollo 11. So he was invited there, and he was a dignitary there to see the launch. Now, other space pioneers, for example, Frenchman Robert Esnault is there, began work on theoretical aspects. Then in Austria, there were Eugen Sanger, who worked on rocket engines, and the late 1920s proposed developing a rocket plane. And Sanger works actually noted by Nazi Germany, and he invited to continue his investigation in that country. And as you know, especially in the case of Germany as well, what you are seeing in the right side is actually the German V2 rocket. Okay, whether should call it as a rocket or missile, that depends. Anyway, if you use it for a usually for a war purpose, then we call it as a missile, basically. Now, in the case this, every country is actually, even initial time itself, interested in rockets. It's not just because of they want to explore the space. Actually, they want to they want to attack someone else using the same rocket. So that is why many countries initially developed the rocket system, and they then change or use the same for the space as well. And that is another reason why they don't share their rocket technology to other countries. They may share other technologies actually, but defense technology, as you know, it will be always the top secret of the nation. So that is why the rocket technology always the people are not ready to share, and they have to make their own engines and all, because it is closely connected with the defense. Okay, so it can be used in both ways. So there are many things in science actually. One same thing can be used in the both way, either the good way or the bad way. So the nuclear reactor is best example. That is, atomic reactor is the positive thing, and at the same time atom bomb is something destructive. So anyway, let's see leave. And it was a space exploration that motivated the members of that VFR club at build their rockets. But in the early 1930s, their work came to the attention of the German military. Okay, so then the German military and that in that team actually Werner von Braun was there, and at the age 20 he became the chief engineer at the rocket development team. And Hitler came to power in 1933, and they actually got a separate place to work with this rocket in secrecy. And this development, actually the purpose wasn't for space exploration anyway. They were actually developed this V2 rocket, basically the ballistic missile. Okay, so they first launched it successfully in 1942, and V2 was used on targets in Europe beginning in, so even it not just developed, they actually used in Europe for war purpose as well. Okay, so the beginning is actually tragic, or maybe a sad beginning for a rocket technology, but anyway, it is how it started. Okay, but built as a weapon of war, V2 later served as the predecessor of many of the rockets used in the early space programs of especially United States, US and Soviet Union. So after the World War, actually many of, especially you can see World War and to near its end in the early 1945, Braun and many of his associates chose to surrender to the United States. So they chose to go with United States, and they relocated to US as well, where they believed they would likely to receive support for the rocket technology. Okay. Later in that year, they were taken to the United States as where their engineers' plans and the parts needed to construct the number of V2 rockets. The German rockets team played a central role in the early development of space launches from United States. So that is the history of that is the importance of Germany, because that is where this ballistic missile came, and both of this the same technology is transferred to United States as well as to USSR. So they were actually beyond the both of them had the rocket technology from there. Then they started the during the after the World War II, there were Cold War, and during the Cold War, that same space war happened, or space race, not a war actually, space race has happened. So United States, so as we mentioned, in 1936, Braun was developing rockets for German military. Several young American engineers led by graduate student Frank Malina began working on rocketry at basically at a part of Caltech, that is the California Institute of Technology. Then Malina's group was supported by the eminent aerodynamics Theodore von Karman. So if you remember this name, that is the Karman line came from the beginning of space actually, or the where the space begins, that is Theodore von Karman. Then Galsit's director, that is the director of this aeronautical laboratory, okay, and included Chinese engineer Quan Xin. Okay, then actually this Chinese person then returned to his home country China, and he becomes one of the pioneers of China rocketry in China. Okay, in 1943, Malina and his associate began calling their group the Gel Propulsion Laboratory, or JPL. Okay, and this same group actually sometimes called with a nickname that is called the Suicide Squad. That is, you can see Rudolph Skold, Apollo Milton, Frank Malina, Ed Foreman, and you can see, okay, that team. So they were nicknamed as Suicide Squad. Okay, then JPL soon became a center for missile research and development for the US Army. Again, it is in 1943, especially it's a time of World War. So they developed rockets for basically did not the space research, the missile research. Okay, following the World War II, those weapons were adapted for use in early US space experiment. Okay, after 1958, when it became part of the newly established NASA, JPL adapted itself to being the leading US center for solar system exploration. So already you know that the JPL NASA is there. Okay. Okay, now Soviet Union. So in the case of Soviet Union, in USSR, the government took an interest in rockets as early as 1921. Then over the next decade, center was expanded and renamed as Gas Dynamics Laboratory. So similar to JPL maybe. Okay. Uh, there in the early 1930s, Velin Goshko, okay, Gloshko carried out pioneering work on rocketry. Meanwhile, other rocket enthusiasts in the Soviet Union organized into societies that by 1931 had consolidated into an organization known as GRID. Okay, that is Group of Study of Reactive Motion. So again, it is reactive motion. Okay. Emerging as leaders of Moscow branch were the aeronautical engineer Sergei Korolev, who had become interested in spaceflight at a young age, and the early space visionary Frederick Stanter. Okay, may not be like this. Okay, so Korolev and a colleague uh, okay, anyway, that Mikhail on 1933 launched the first Soviet liquid fuel rocket. Okay, so these are all test rockets, not to the space. It may not even reach the space, but these are all some test range. And later, actually, again, you can here see that by the end of the World War, Stalin had become interested in ballistic missile, and he sent a team which included Korolev on visit to Germany to investigate the V2 program. Again, they investigated the V2 program. But anyway, a number of German engineers, similar to that of US, okay, German engineers also relocated to USSR or the Russia as well. But they did not play a crucial role in the post-war Soviet rocket development. Okay, most returned to Germany in the early 1950s itself. So actually, they studied V2 rockets. Anyway, V2 rocket is the kind of the beginning of all. So that is where it all started. So then here comes the space race. Okay. Then the space race was a part of broader Cold War rivalry between the United States and Soviet Union. It began in 1940s and late 1940s. So that means it is late 1940s means it is near uh, after 1945, something around 1947, 48, something like that. Okay, so it is anyway post-war, post-World War actually, during the early stages of the Cold War, and it is something like a showing off between the superpowers. At that time, the superpowers were actually USA and the socialist uh, state, that is the USSR. So they were actually showing their capabilities. It is not just in the case of space, but in every technological or scientific achievements, they were actually trying this. An interesting story regarding this, as they had a race to go to the space as well. The same way they actually try to go into the deepness of Earth. Actually, how far they go inside the Earth. So there is an interesting story related to that as well. Okay, then both nations used space exploration as a way to gain international prestige and demonstrate their technological dominance. Then officially, if we ask something like when the space race began, it is actually by the launch of Sputnik 1 by the Soviet Union on October 4, 1957. Okay, so this October 4 is when the actually that space week happens. Okay, that is in October. It is in it's a commemoration of actually the first satellite, that is a space race. So that is the launch of Sputnik 1 and is widely considered the official start of the space race. Okay, so this is the official start of the space race, that is with the Sputnik 1. And especially when the Sputnik 1 was there, Sputnik 1, it goes through the sky and even it orbits through above the sky of US itself. And at that time, actually, this Sputnik can actually So whether it reached or there or not is actually found by the antenna. So antenna is emitting a special type of radio waves in a specific band. Actually it can be tuned with the radios. So that actually, when the US actually go to see this or go to receive the signal, they actually got panicked because USR is that much advanced to have this thing, then they can easily attack us. So there is a fear between, especially for USA, and they actually started accelerating their space program. In response to that, they actually sent their first space satellites, their satellites to orbit, that is Explorer 1 in 1958. So just see, after just seeing this, anyway, they were not just started at that time. They had the technology maybe uh, even before, but with the initiation from the uh, USSR, they actually began working fast and accelerated. And within a year, actually, they were not even it even, yeah, it's took almost a year and 1 or 2 months. Okay, no, it's just some months actually. October, November, December, Jan. So within some 3 months, actually, they were able to launch their first satellite, that is Explorer 1. Okay, so this is the chronology of or the major launches that happened between Soviet Union and United States during the Cold War period. So October 4 denotes the launch of Sputnik 1 and the beginning. Okay, then Sputnik 2 with Leica, launch of Explorer 1, Luna 2. Then Yuri Gagarin in Vostok 1, that is the first human in space. Then Alan Shepard, you can see it is, this is in April, this is in May. That is, there is not even a gap of 1 month even. So see, that is the similar way they had all these launches, and it was something like a uh, and everywhere actually you can see almost the first is almost always for Soviet Union. And finally, especially, there is an important speech by John F. Kennedy, that is written as the JFK. Sorry. So you can see here, this is JFK's moon landing speech. So in 1961, John F. Kennedy given a speech in which he said that the USA will send a man to moon within the end of this decade. That means in 1961, he said in the same decade, 1969 itself, they actually had the Apollo mission in July 20, 1969. Okay. So that is Apollo 11 moon landing that happened. Then Apollo 12 to 17 mission, United States. Then 1971 Salute on, that is a space station, that is again by Soviet Union. Then again Skylab, another space station by United States. And there was one more, I think that is after the end of the Cold War, that is Mir was there. Another, anyway, they are not, any of them are not active now. Okay, they lost even in 1990s itself actually, and before 1990s or around that time, Mir was still there. Anyway, now it's only active is International Space Station. And this is 1975 July 15 is the official end of the space race. And that's a very good ending, actually a positive ending. That is, you can see that particular mission, Apollo Soyuz test project, that is, you can see in that country list, it is not a single country name. You can see it is USA and USSR together did that mission. Okay, so Apollo Soyuz, okay, test project. So it is actually, it is a first international space docking. So international space docking in the sense that docking happened even before that, especially for moon and everything, the docking technology is needed. But international space docking means the docking between two different countries happened in 1975, that is between USA and USSR, and that is officially taken as the end of space war. Okay. Okay. Now, collaboration and end of the space war. I say. So, Apollo US test project 1970 marked the first US Soviet mission and symbolized the end of space race. So, it involved docking a US Apollo spacecraft with a Soviet Soyuz, signaling the beginning of space cooperation. The event shown a shift from rivalry to the easing of Cold War tension. By the 1980s, both countries began focusing on the long-term space presence and scientific cooperation. Then anyway, you can see the space race actually, it's kind of if it is a war, the war should be like this. If you want to have a war, the war should be like this. Is how I want to mention about that, because it's anyway nothing, no kind of an active war happened. It was a cold war, so they were showcasing who is better. So it actually developed the rocket and satellite technology and led to innovations, telecommunication, weather forecast. So when the especially in the case of a rocket technology, okay, other than when you compare with any other thing, as I mentioned before, so rocket technology is associated with the many different branch of sciences. Okay, it involves physics, it involves engineering, all branches of engineering, computer programming, computer chip, IC chip, electronics, everything comes into play in a single mission. Okay, so when we develop a rocket technology, it actually helps to make new material, new technology, new advancement in every field actually, not just one field. Okay, so for example, if I make some car engine or something like that, it may improve basically the mechanical engineering part, some advancement, maybe some chemical, some fuel kind of thing, maybe some acid. But here in the case of everything will work, and we need a very advanced thing as well. Not we cannot have a simple thing. So it should be so accurate, precise, and we need advanced technologies for this. So this all actually happened during the Cold War, very at an accelerated pace. So if the Cold War wasn't there, maybe the space technology would have delayed by some 10 years, 10 to 20 years. So that is how we can. But anyway, we cannot. Anyway, this all these technologies will be invented. That is for sure, and we will go to moon, or all these things would have it happen, but may not be in this short period of time. Okay, so it might have been delayed. Okay, so to some 10 to 20 years. So that is the importance of this space race. Then that is about the now some another important mission, a single type of a vehicle, if you want to mention, that is actually the space shuttle missions. Okay, there are many other vehicles actually, even by NASA and Russia are there, but space shuttle is another important one because of its uniqueness in the sense that it is not a usual rocket. That is why I have included. I'm not saying that any other countries doesn't have any good rockets. They also have rockets. Okay, especially Russia's rockets are actually famous for its reliability. That is why even USA, after the space shuttle program in 2011, they doesn't have a good rocket with them. That is a reality. They have some Falcon and all that is actually from SpaceX, and before that they are actually using the vehicle of Russia actually. So that is why I said that every country has some reliable vehicles actually. But anyway, why I'm giving importance to space shuttle, because it is a unique kind of vehicle in the sense that it is a reusable transport vehicle. So in every case, you know that once a rocket is used, it becomes completely useless. Okay, no part is actually reused again. Maybe some boosters or something may be used, but anyway it is almost useless. Okay, or it is a one time go. Just imagine that if you want to go from your home to your uh, school every day, you are taking a car and going there and leaving the car there and coming back again. The next day you will buy a new car and going there and coming back. So that is how the rockets actually work. Okay, but anyway, for returning there will be some method, but that also cannot be usually reused. But anyway, this space shuttle mission is unique in the sense that it is reusable. Okay, and you can see it is one of the powerful kind of launch vehicle, so that it can carry 29,500 kilogram into low Earth orbit. Okay, so this is its design is something like this. It consists of three parts: the orbiter, an external fuel tank, and two solid rocket boosters. So this the orbiter is this actually. You can see this looks like exactly like a flight. Design is almost like a flight, but it also has a jet engine is there or something like it's not the jet engine, so it is actually rocket fuel, not air is not there. So jet engine works differently. It need air to breathe. But anyway, here this is the again rocket engine is added to that. Along with that, this is the fuel tank we mentioned. See, this is the main fuel tank, liquid fuel tank, and along with that, two solid boosters are there in the side. Okay, So the orbiter was reusable and capable of runway landing. So advantage is that this can go like this, and when it comes back, okay, it can land like an aircraft, something like a flight landing on an airport. It can actually land capable of a landing to a runway. Okay, then external tank was used for the launch and discarded during the ascent. So the ascent itself, this main tank that you are seeing here, this will be discarded, but the solid rocket boosters were recovered and reused. So except this orange, maybe red or brown colored thing, everything is actually almost reusable. Okay, so anyway, we need fuel that is not reusable, as you know. So these are the major features of a space shuttle. And a fleet of 4 orbiter was built. So not just one, they actually built initially 4 of them. The name something like, they are named Columbia, Challenger, Atlantis, and Discovery. Okay, so these were the 4 of them. And first shuttle took place in April 12, 1981. Then the cost projections were inaccurate. Each launch cost hundreds of million actually. So even though they thought that it is cost effective, but it is not that cost effective. The highest flight rate was 9 in a year, was short of the expectation. Then the first issue comes, that is a Challenger disaster in 1986. Okay, so it just exploded just after the 73 second after the launch. That is a picture that you are seeing at the bottom right. That is a photograph of the explosion. Okay, so the issue was with a minor issue, something like that fuel tank has an O-ring. So O-ring is kind of a rubber seal. Okay, so it is something that you might have been if you have an experience with a pressure cooker. In that pressure cooker, you can see there is a rubber gasket is there, a circular type ring, a rubber ring is there. That is actually make sure that there is no leakage through the side or at the contact point. Okay, so that is why it keeps tight there. Okay, but in the case of this Challenger, see, this happens in January 28, and this O-ring was not properly tested for temperature variation. That's something like, if it is a cold weather, this becomes, since it's a rubber thing, rubber kind of O-ring, and when it becomes at a very low temperature like the winter, because January is actually winter time, so in that winter time it becomes brittle, and actually the booster struck the external tank, lighting the fuel and causing the explosion. Okay, so solid rocket booster, it is something like this. Okay, so from somewhere over here, after 73 seconds, some leaking happened, and that leaking caused the burning of this entire thing. Okay, so it has to be controlled flow so that it can burn, but here what happens, we cannot control it, leaked from here, and it caused the burning of the entire main engine, or main that liquid engine. So that is how it exploded after the 73 second. So then after that, anyway, they replaced that Challenger by another one called Endeavour, that is another space shuttle. So total number of is actually 4 plus 1, that is including Endeavour. Now, shuttle achievements, post Challenger safety protocols were strengthened. Then the shuttle demonstrated capabilities like satellite repair in orbit science, that is example of the Hubble Space Telescope. Then 1998 onwards, shuttle helped in assembling the International Space Station. Okay, shuttle conducted 37 missions related to International Space Station. So you can see, even if you include the Challenger itself, there were only 5 of them. Okay, 5 of the spacecrafts, maybe space shuttles were there, but they actually had 37 missions dedicated to ISS itself. And you can see, then later comes the 2003, that is Columbia disaster. So in that Columbia disaster, that is it, the disaster happened during the re-entry actually, when it is coming back actually. So during the re-entry, something happened with the heat tiles, and that is caused the Columbia disaster. Okay, and the problem, then after that, actually there were a pause, and they were actually confused whether to continue it or not. Then actually in 2004, George W. Bush announced that shuttle would retire after ISS assembly. So after assembling the ISS, when that job is completed, they will retire all the space shuttles. So then onwards, there is no reusable launch vehicles are there for NASA. So anyway, then I mean government organization, particularly NASA, that other space agency has something like the that Falcon and all. You know that is different anyway. Uh, okay, then retirement and legacy. That is, you can see the final occurred in uh, 2011 July, and over its lifetime, the shuttle flew 135 mission. Okay, and launched 355. So it is one of the successful mission or a launch vehicle that had in the history of space flight actually. So that is the space shuttle. Uh, and Columbia disaster, as you know, that the Indian origin uh, Kalpana Chawla and the team, that is the photo here. And even in both the disaster, actually, nobody escaped. Okay, nobody were. So that happens in the rocketry history. It's something like we cannot even. There is no. We cannot even help anyone. So it's usually we lost the people completely. Okay, so that is about the space shuttle. Then comes the International Space Station, or this is the internationally collaborated space station. Other than Mir or Salute or something like that, they are actually by US and US and USSR. Now, International Space Station is actually something planned by US. Initially, actually not planned by US. In a way, we can say that US actually had a plan to build their own space station called Freedom in 1980s. So then, actually, the high cost and technical delay led to redesign and for an international collaboration. So when it is led only by a single country, the technology has limitation and the funding has limitation. So it is better to have a corporation. And in 1993, US and Russia merged their separate plans, and ESA and Japan joining as key partners. The project includes contributions from Canada and 11 ESA member nations. Not all the European Union members. 11 members were joined. Okay. Then assembly and expansion happened from 1998 to 2011. So 1998, first module launched. The name of the first module is Russia's Zarya, then followed by US module Unity, then 2000 Swesda module, then first crew. So first crew happened in 2000. Okay, within 2 years actually, people were able to arrive at November 2, 2000. Then construction continued with the addition of all this Destiny Lab, Columbus Lab, Kibo Lab, Dexter Robot, etc. Then that is how it happened. Okay, completely. And this is just a small animation of how they arranged or how it is expanded one by one actually. So you can see there is new components will come and join. Also, there will be redesigning also happen. So it is not in the initial. You can see that solar panel and many things will change the sides and as well. So it's arranged in different manner. See, so even this is not in complete. I think there are many modules actually added later. So that is the International Space Station. So okay, and why we are actually having this International Space Station at this high cost and collaboration. So the main thing is actually a microgravity lab. Okay, where microgravity, because we said that it is equivalent to having zero gravity, but even in that zero gravity there is a kind of gravity because of all the instruments. So this space shuttle itself a big thing. Okay, so it can also give a tiny gravity, that is called the microgravity. So for there we can actually have many type of experiments: space technology testing, material sciences, then life science testing, how a plant will behave, how something will grow, how bacteria will grow. So many things can be studied there. Okay, so current status is something like ISS has been continuously inhabited since 2000, and more than 200 astronauts from 20 plus countries have visited International Space Station and US. ESA, and Japan and Canada plan to support ISS through 2030. Then Russia plan to exit in 2028 and develop its own space station. Now let's go to a brief, okay, very a synopsis of or a small timeline of the major incidents that happen in the history of space exploration. I'm not saying that, I cannot say that whether it includes the complete major things, because this happened during some, even it is something like from, even you take it from 1990, it is almost some 25 to 35 years already. So 35 years of space exploration anyway cannot be added to a single or two slide or even in a 1 hour session. So anyway, that is, I am giving some brief important thing, that is like the 1990 Hubble Space Telescope launch, and 1995 Galileo arrives at Jupiter, that is an orbiter to Jupiter. Then Mars Pathfinder plus Sojourner, that is the first successful rover on Mars, tested new tech for. Then International Space Station assembly started in 1998. Their permanent crew begins on ISS. So it is something like we have a permanent stay there. So it is an outpost for us, okay, in space. So still imagine that that is actually moving around us. So that is, just a second, I will show you an interesting thing. Yeah, this is actually the site. I think I had already added the site that. So if you look this, it is working. Okay. Sorry, just a second. So this is to spot where it is. Actually, you can, one more interesting thing, you can actually see ISS from ground, something like a bright satellite, bright star moving through the sky, something sometimes as bright as that of Venus actually. For that, you can actually get app in your mobile phone, like the ISS tracker. You can see it is here. Okay, so yeah, this is how it goes. You can see its speed, at what latitude and longitude it is right now, at what height it is right now, etc. Okay, so this is an example, and you can install that app and give it will automatically give you a reminder when it arrives to your night sky. Especially in day sky you cannot actually, but in the night sky you can see it as moving across the sky as a bright star actually. So that is another thing. Okay, so that is about the International Space Station. Then Spirit and Opportunity rovers, Cassini-Huygens mission that we discussed yesterday actually. Spaceship One, first private manned suborbital flight. New Horizons launched to Pluto. Then Chang'e 1, that is the first Chinese lunar mission. Then final space shuttle flight, STS-135, that is in 2011. SpaceX Dragon docks with ISS. Then Curiosity rover lands on Moon. Chang'e 3 soft land, first soft landing on Moon since 1976. After 1976, okay, it is not about the very first one. Then 2014 Rosetta and Philae, that is the first landing spacecraft landing on a comet. Then New Horizon flies by Pluto, a year in space mission begins. Then ExoMars Parker Solar Probe to Sun, etc, etc, etc. Okay, you can see JWST in 2021. That is one you may remember. Okay, that you might be remembering that. Then Artemis, of course, you might seen the launch and all. Then Chandrayaan 3 lands near the moon south pole in 2023. So this is the overall, okay, yeah, a brief history of space. Okay, there are many missions actually I missed in this for sure. That is, I'm definite, because there are a number, and I suggest you to visit there is a page called if you go and search for history of or timeline of space exploration, then you can get a Wikipedia page where everything is actually written in a table. You can get each and every details of that, and it has a reference as well, so it is almost accurate. Anyway, you can actually, anyway, when you get data from Wikipedia, you have to double check whenever it is, whenever you're getting data from other than any official sites, then you have to actually double check it. So anyway, but Wikipedia is almost correct. We can actually almost reliable one. So you can see what are the missions happen and how numbers are there. I had a plan to include all of them in this, but the problem is that it need at least some 20-25 slides to include all those launches. Now let's go and see the major space agencies that are right now. Okay, I'm actually just giving you a brief idea about that. So some factual data that is better to be learned with a table because it is easy to compare and learn. That is why I put in a table. But each of them can be learned as a separate class itself about each of the space mission or space agencies and about their history and the major missions and everything. But I have given something like this. Okay, you can see I'm not going to discuss it's one by one, reading it once again. I don't think it's needed. If needed, you can tell me, I will do that. But compare some of the things, something like the annual budget. See, so whenever the name of a space agency, the one thing that comes to your mind, or whenever you read the space news and all, the most of the news are coming from NASA because of the main reason, because they are pumping this much billions of money into space research actually. But when compared with the other countries, you can see other countries it is just a single digit. This is a double digit. Only they have a double digit, and $5 to 10 billion, maybe for 5 to 10 billion for private players like SpaceX. It's also there. And you can see one more thing, NASA is actually cooperating with the SpaceX, so that maybe in coming year, SpaceX will also get a high funding from NASA. Already they are actually collaborating. Then you can see the future, the major human missions. You can see not everyone has, and for India, this is a planned mission. It's not yet happened. Gaganyaan will happen in future. Then most of them are ISS partners, and China right now has their own space station, and India is also planning their own one. That is a Bharati Antariksh Station. So planetary missions, you can see all this. Then satellite programs, the major of them, not everything. So if I want to give the satellite programs, each of them, I need an entire page or more than that, because that much number of satellites are there. Okay, but anyway, you can just note down this is GPS, that's their navigation system. Galileo is by ESA, then JAXA doesn't have any, but any Russia has GLONASS, then ISRO has NAVIC. They are the regional navigation satellite systems. Okay, then reusability focus. Now they have SpaceX have high reusability focus. Falcon 9 and Starship is there focusing, and India is also developing its reusable launch vehicle. Then these are all. This is the private player there. Okay. Now, future missions, you can see these are all the planned future missions as well. So this is briefly about the major space agencies. You can go through, and also you should read more about them, especially about the history of space. I will include some at the end of this slide. When these slides get will reach you, I will give you some reference links as well. Some of them which I used even for creating these slides, and also other than you can actually use for extra reading. It would be better for you. But the thing is that don't worry, that will be a long link and all. But in the question, that will only come from my class, okay, or the slide till now. Okay, whatever I discussed in the class and whatever was there in the slide when I was taking the class will be there. Okay, but I'm not saying that whatever I said will be there in the exam. Not everything in the slides will come, but the reference part you can, or something like I will written as additional readings. Okay, so you can use it later for your knowledge enrichment. Okay. So now let's see another interesting thing called as spin-offs. So spin-offs means it's a technology that is actually developed for a particular reason, and it becomes accessible to civilian purpose or common man's usage. Okay, so that is something called the spin-offs. So many of the technology that we use today comes from basically when they do for example, you know that NAVIC is actually the regional satellite navigation system for India, and it is actually for the developed for the military purpose. But a part of it is actually given to the common people's purpose for navigation. So that is how it is. So similarly, there are many space spin-offs are there. And one more interesting is actually the initial form of internet, something like a networking. The networking between the computer actually happened not for purposefully for internet. Actually, it happened for data sharing between the computers of that CERN. Actually, CERN, you know that the particle large hadron collider and the particle accelerator actually. So for CERN had a network initially, and that is a basic form of internet. A networking happened. Okay, so that again used for other purpose. That is another best example of spin-off. So a technology that is developed for a small application or a small tiny region or for a specific purpose, later it become popular for and accessible for every human being, something like a uh, uh, for civilian purposes. Those kinds of things are usually called as spin-offs. Sometimes they also use the term other than spin-off, they will use the technology transfer as well. So there will be a technology transfer happens from the space to other industries. Okay, or that is it. So one best example, many examples are there. One of them is actually the cordless tools. Okay, so especially in Apollo mission, they when they went to moon, actually they want to drill the surface of moon and to see what it is there, and that is the first time actually they develop the cordless drill bits like things. Okay, and the cordless tools basically. So you know that cordless tools are there right now. It's common, but anyway, that is actually developed for NASA mission, and that same idea is used for even for cordless vacuum cleaner and all. Okay, so and just it has to work just with the battery, so it is not that easy. You may think that just simply connect a battery, but it has to produce high torque or high powerful drill is there, so it is not that simple. So it need a specific. The another one is actually scratch resistant lenses. So when you go to space, actually space debris, tiny space debris will be there when you go for space walking and all. Your glass may get scratched. Okay, so to avoid that, they developed a coating. But the space application, you know that it's limited, but every glass, every specs that you make when you go to the uh, spectacle showroom or something like that to buy, they will anyway you will say this is scratch proof or something like that. Even the phone displays, you know that it comes as scratch proof. This is all technology actually came from the space. And another thing that is came to the phone itself, that is the digital camera sensor. So one of the cheap kind of and very effective and fast sensor that is used in camera is actually a sensor called a CMOS sensor. Okay, there are many kind of sensors are there, and right now in all the digital cameras that you see around, even in GoPro or your phone, or maybe the professional camera that uses for photo shoot and all, you can see that all this consists of a sensor called a CMOS sensor. So this CMOS sensor is actually first developed for space actually, to especially for making miniaturized cameras and all. Okay, for interplanetary missions. So and miniaturization is also important in that sense, because you know that especially if the mobile the camera has to come to a phone or something, it has to be miniaturized. It should be a small in size, but it designed for space because to reduce the weight. So reducing the weight is that important, especially even each gram is actually counted. So that is why they try to reduce this thing. Then the second thing is enriched food. So when you're having food and ground or something like a daily in your daily diet, actually uh, ideally it should include all the macronutrients and micronutrients, something like zinc, potassium, iron, etc. Okay, so but if we have many type of foods, if your food is so diverse and all, then you will automatically usually get this from all the different food that you're having. But if you are in space, you can not actually take all the kind of foods to space basically. So the problem is that one is then if you want to include a particular macronutrient, then you have to include some 1 kilogram of something. So it is not that good, or is not, it is heavy in akin. Okay, it is not cost effective. That is why a certain food can be enriched with the other sources. Okay, so other sources of maybe zinc or potassium or whatever, iron, whatever needed, that can be enriched in a certain food.
Okay, so that is actually called the enriching food. So this enriched food become baby food actually. Okay, that is actually developed for astronauts, but now the babies around us actually having it's more than that. Maybe the not exactly the space food we are having, but the same technology. And another technology regarding the food, which is not included here, you may know that there are dried foods or something like specially packed food are there. Something like, assume that there is a curry, usually a curry like thing, some what to say, some liquid like thing, something like a curry or some is there, that cannot be usually packed and saved in shell for 6 months or 1 year. It's not possible. Okay, maybe some nuts and all you can store for a long time, but otherwise you cannot actually store, especially the fluid form food we cannot actually store. But there are methods, especially that is used in space technology as well. And you might be knowing some kind of noodles which is almost dried, but when you pour hot water, it becomes a normal noodle. So all those technologies are actually created or developed for space missions, and nowadays we are all using that. Another one is the memory foam. That is also a NASA spin-off. Okay, it is designed for, especially that when they go for the flight and all, the seat should absorb the shock completely. That is why they made the memory foams, and that is also, we know that every bed might have that actually. Now, water purification system, firefighting equipment, insulation and thermal protection, structural monitoring system, then a material for left ventricular assist device, that is from ISRO. So there are many. There are multiple kind of spin-offs are there. This is not. This is just a beginning. What you are seeing, the major ones and popular ones, and but there are many simple things that is actually connected with the. These are all there. So even if you go and check for Apollo space program spin-off, you will get a number of them. Okay, I will show you another interesting site by NASA again about the space technology. You can see this is the home site, spinoff.nasa.gov. So just go there and click on the NASA home or city. So then they will show you explore city or home. You can click either, whatever you need. Then they will take you to this site. Okay, not here. Just a second. Okay, let's go from here. So let's explore home. Okay. Now you can see this is a home. Ideally, this is a home. Now, what you can do is that you can actually move and click the living room. So now I click the living room. Now I click this. There is a glass. So this blue light cancellation, this visors are actually designed about space. Okay, you can read more about and learn more about it. So it's an interactive thing. So something written here. Audio equipment. I don't know what it is. Not all acoustic gesture are equal, and NASA Aerospace Technology and Industrial. Okay. Okay. He also built the body out of fiberglass compost or rotor. Okay, used for rotor blades. Okay. It is also something used for rotor blade, actually used for the body of this guitar actually. So that is, it's also there. Okay. So if you once again go to the home, let's explore one more place. Okay, now let's see. This is living room. This is, let's see the bathroom. What is there? Okay, let's see the flush. Environmentally safe sewage treatment. Okay, so that is also developed for space. Skin creams. Oh my god. Okay. Then infrared air thermometers. Yes. Okay. Then okay. Anyway, you can do that. What is this last one? Oh, uh, polished brass finish. Oh, that is even for space. That came from spin-off. Osteoporosis treatment. Okay, that is some medical related things. Okay, anyway, that's it. You can explore it later and you can read about more. Okay, so now about your exam. So regarding the exam, as you know, the total number of questions is 30 and 50%, that is half of the questions will be from your textbook. So there is a textbook available for A syllabus based textbook is available for your International Space Olympiad, which is available from the International Space Olympiad website. If you couldn't access it from there or couldn't buy it from there, just contact EduMitra for the textbook. Okay. The second thing, 30% is from this training, this 5-day training, you get 30%. So 15 questions from half of the question, that is 15 from textbook, and 9 questions you will get from this 9-day class. Okay, sorry, 5-day class, you will get 9 questions. So almost every day you will get 2 questions. Okay, and that will be from the online training, and those questions you can actually work out later. When the slides receive you, also you can learn from the, and slides will be received by email to each of you, so don't worry. Then mode of exam is online, as same as before. You know that the beginning, the beginner level and intermediate, so it is the same way it will happen, and the right answer carry 1 mark and the wrong answer carry minus 2.25 marks. Okay, so quarter of mark will be reduced if you go for any wrong answer, but anyway you can leave any question. Okay, so if you don't know that, you can actually leave. If you leave a question, there is no negative marking, so don't worry about that. So if you don't know it's completely, other than going for a wrong answer, it is better to leave. Okay, so this is the mode of questions. And okay, I think, yeah, then one more thing, for multiple choice question, you already know that you A, B, C and D options will be there. One way you can answer is actually, if you know the right answer, suppose D is the right answer, you can go and choose right answer easily, no confusion at all. In the second method of answering the uh, answering the MCQ is something like, if you know, if you don't know the right answer, check for the other options, something like option A, option B, option C. And when you see option A, option C, B and C, I know that option A is incorrect, option B is incorrect, and option C is incorrect. So choosing what are the wrong or selecting what are the wrong, then from that also you can actually rule out the wrong and find what is remaining. So that is also another method. And if sometimes when you want to guess, if you don't know all the 4 of them, no familiarity or uh, no idea about any of the options, then it's better not to go for a guessing. So if you want to go for a guessing, you should be at least sure that, oh, it should be B or D. Then then if you go for a guessing, it is better in the sense that there is 50% chance of getting it true, getting it right. Okay, so that is why in that case you may go anyway. That depends on your choice, depending on other answering, if all of them are correct or something like that, whether to go for, it's your choice. Anyway, this is some ideas that we can use in the case of examination. Now let me take questions from the chat. Okay. Sir, what pattern of exam? Okay, that is already described. Sorry, about yesterday's session, how do researchers calculate the mass of celestial bodies? So, mass of celestial body, I am anyway not going to deeply tell you. For example, this is one object and this is another orbiting object. Suppose one planet and its satellite. Okay. Now I can use the same equation, mv square by r, that we used last. Then g m by r square. Okay, now I can cancel this r and r out, then m and one m out, then I can actually calculate this m by rearranging all these things. This is one simple crude way, not the crude way, anyway, this is one method of actually calculating. So I think this type of questions will be there in your higher classes, where just with the orbital period of moon you can actually calculate and to the distance of the moon you can actually calculate the mass of earth using that. So there are methods for that. So that is one example. Then what is V2 program? V2 program is actually the ballistic missile development program of Germany, by the Nazi Germany. That is the V2 program. So can this table come in exam? Yes, of course. This table means the data from the table may come. But anyway, other than some famous date, something like when the first moon landing happened, that date is so important. Especially we celebrate that date actually.
So or October 4, that is an important date. So those kind of date can be come, but anyway there won't be question like when the shuttle mission stopped in which date. Okay, so in the year may be asked but not the date, so that is not that important date. So important dates are only one or two or three or four, maybe I'm considering my class that what I am saying. Other than that I cannot say because I am not the one who is responsible. But anyway, important dates should be remembered. That is, especially when that day is being commemorated as something else, like the Space Week or Space Day or Lunar Day, like that. Then that is important. Actually, that you should uh, aware of. Okay. So, sir, is Apollo 11 mission is true? It's for sure true. Nobody has ever proven that is Apollo 11 mission is wrong or it is a fake thing. Nobody has ever, in the sense that there were some people who go for hoax theories and all. They actually had some hoax. Other than that, especially just think that this happened during the Cold War, okay, or the space race. And first people to disprove NASA is actually who else? We already know that it was a race between USSR and the USA, and USSR should have came with the evidence that you are doing it wrong. There is no way of having this. But see, USSR doesn't came with that. That means actually they might be the first one to debunk or to say that this is fake, but they haven't. And one more, there are many uh, argument that is coming from this Hawks theories actually, but everything has its own answer, and you can actually just there is a Wikipedia page dedicated to that. Every argument is there, and it has a clear answer as well. And just think simply, it is actually it is even the lunar rocks are actually collected, and it's been sent to almost all the major space agencies were there at that time. Okay, and nobody were able to identify that it's unique. Nobody were able to identify that this is uh, from Earth actually. So no scientific proper scientific community doesn't came with any argument that okay. So all the things that you're hearing is some Hawks theories. Top 15 question is directly from the textbook or twisted or diverted. I think the textbook consists of MCQs. Might be direct MCQs can be taken from that, and there is some long answer type of questions are there. So from that long answer type, anyway, it becomes multiple choice. So there will be some changes, but the idea will be the same. So that is a so in the textbook, you have to learn MCQ like and the paragraph answer. So paragraph answer in the sense that you have to by heart it or anything. So you have to know the idea. Questions may come from that as well.